Okay, let's take some notes. I'll make sure I keep my copy in. Polynomial end behaviors. So we're looking to see what happens to functions no matter what degree they are. So find my pen here. So we start off by just labeling different types of functions. So our first one, degree 0. I don't know why it's got a fancy 0. Don't feel like that's anything special. This is a constant function, and that's just a horizontal line. We're not going to deal with those too much, but there it is. Then we move up, degree 1. It's a linear function, so that kind of looks kind of like that there, right? Nothing fancy. Y equals mx plus b. Our second degree is a quadratic. Hopefully you recognize at this point it's a parabola, it's that kind of U shape. All right. The next three we don't see quite as often. Third degree is a cubic function. And so the general idea of this is something like that there. So it goes up, comes back down, goes back up again. Okay, it doesn't have to be perfect, doesn't have to look exactly like that. You just need like this one little humpy deal and make sure it heads off going up. And then we keep going. So let me make sure I spell this right. Fourth degree is called quartic. And this vocabulary is not a big deal. So how this one looks, it's kind of like a W. So you go up and then down, and then up again. Kind of fell off the graph. Okay, so it loops. That's fine. Comes down, comes back up, goes down, comes back up again. And hopefully you're starting to see kind of a pattern here. And then our last one is quintic. Quin for 5. And then this one's going to start at the bottom. So you go down, up, down, up. There we go. Okay. That's the general idea. And we're going to talk more. These pictures will make more sense once we do the next section here. But that's what our functions look like in general. Okay. So what we want to write about is the general behavior of our 4 different situations. Okay. So the degree of our function is either going to be odd or even, and the leading coefficient is either going to be positive or negative. So let's start off with the easy one. Let's start with an even degree with a positive leading coefficient. So that would be something like f of x equals x squared. Right? Or if you want to put a number in there, you could say 3x squared. Okay? So when we say degree, we're talking about the highest degree of that function. So even if I added like negative 10x minus 55, right? We're only looking at this first coefficient, and we want to know, is that positive or negative? And everything else does not matter. It's not going to change what it looks like. Okay? So if we have an even degree and a positive coefficient, our graph would look kind of like this. Okay? And then we want to know if we take this all the way to the extreme, because the domain of any function is all real numbers. Hopefully you know that. We want to know what happens if we go all the way to the left or all the way to the right. So we start talking about this idea of infinity. More about that later. Which is like it's like your first baby calculus lesson. So I'm going to try not to stress you out, but I'm going to write this out. We're going to say, what happens to y? Make sure I write this. It's been a while. What happens to y at positive infinity No, I did this backwards. Okay, hold on, I'm just gonna write it. As x approaches just going to write it and then I'll explain. So I think that'll make more sense, to me at least. So we're saying y goes to positive infinity, which means it's just going up forever as x goes to the right forever. So as x gets bigger, y also gets bigger. And hopefully that makes sense, because as you go further out, if we increase the value of x, right, y also goes up with it. Okay? And then we look at the other side. So what happens, and if we write this backwards, what happens as x gets smaller? So as x approaches negative infinity, as we go to the left, what happens to our y value? And you see, well, Ellis, it's still going up. You're like, that is true. So you say f of x approaches positive infinity as x approaches negative infinity. Okay? So if this is the case, if your degree is even, leading coefficient is positive, it means no matter which way you're going, if you're going to the left or to the right, your y value is getting bigger. That's the whole point. Okay? So let's look, what if we flip that around? So what if we said even degree, but with a negative coefficient? I want to know, what is the end behavior? So if we have a negative coefficient, so that'd be like y of f of x is negative x squared. And you know if a is negative, then your parabola opens downwards. And you say, ah, I see what's happening here. So now if we go to left or to the right, y is going down. So we can say f of x is now going to approach negative infinity as, and actually let's do left first, as x approaches negative infinity, and f of x does the same exact thing as x approaches positive infinity. And I know all these infinity signs are a little confusing because you've never really seen them before, but you'll get used to it, hopefully. So all this is saying is that if you go to the left or go to the right, y is going to decrease. Okay? And that's even number functions. So even functions are a little bit simple because they're always going the same way. If it's a negative leading coefficient, it's going to negative infinity. If you have a positive leading coefficient, it's always going to positive infinity. All right, and then on the other side, we have our odd functions. Oh, no, sorry. I didn't mean to say odd functions. That's a different thing. Functions of an odd degree. That'll make sense later. But I did not say odd function. All right, so an odd degree, positive leading coefficient. So that would look like, which one did that put? I put this. Okay. That's like this here. Okay. If you don't believe me, you can graph it. This would be like f of x equals x to the third power. Okay, it won't look exactly like that, but it's got this general shape. And we can see here, now it's going in opposite directions depending on if I'm going to the left or I'm going to the right. So what happens, and again, let's start backwards here. What happens as x gets smaller? So as x approaches negative infinity, we see that our y value is going down. So we can say f of x approaches negative infinity as x approaches negative infinity. So we can see in this case they're going together. As x gets smaller, y gets smaller at the same time. Okay? And then on the other side, that's also true, only now as x gets bigger, y gets bigger. So we can say f of x, f of x is approaching positive infinity as x approaches positive infinity. So that's our rule here. If you have an odd degree, positive leading coefficient, x and y are both going in the same direction, right? As x gets smaller, y gets smaller. As x gets bigger, y gets bigger. Not too bad. And then our very last one, which hopefully at this point, you kind of see the pattern. we have an odd degree and a negative coefficient, negative. So that'd be like f of x is negative x to the third power. And that one's going to look not quite that sharp, but whatever, I'm not an artist. Okay, so we can see here, now they're going in opposite directions. X is getting smaller, but y is getting bigger. And then on the right, as x gets bigger, y gets smaller. So we would write that out. We could say f of x approaches positive infinity as x approaches negative infinity. And then the opposite is true on the other side. F of x is getting smaller or approaching negative infinity as x is getting bigger or as x is approaching positive infinity. Okay, so odd degree, negative coefficient, x and y are going opposite directions. Okay, so we need to go back because this is all the answers, basically. Every single graph you're going to see is going to match up with one of these four situations. Like if we look at an example one here, number one, you can see they're both going up. So that means it has to be, so they're going the same way, that has to be an even degree. And since they're both going up, then it has to be positive. And even though it's not the same drawing as this one here, all this little extra lump here, this just means this is a f of x is x to the fourth power. Right? That's what the extra lump in there we saw at the very, very beginning. Okay? But really, you're just looking at the endpoints. So if you see them going the same way, it's got to be even. If they're going opposite ways, one's up, one's down, then it's odd. And then to know negative or positive, we just look back to our four rules here. So every case you're going to see is going to fit into one of these four categories. Okay, so good luck. I know that seems a little confusing, but I feel like once you start doing the problems and you get in the hang of it, you'll be like, oh, this is cake. So good luck. Let me know if you have questions.